Hello everyone and welcome to our first pattern, that is CQRS. I'm gonna let you know that what the advantages you can take by applying that pattern and what are the basic concepts about the CQRS. So let's start with the definition of CQRS. So CQRS is a command and query responsibility segregation principle. It is a software architectural pattern that distinctly separates the responsibilities of reading data like queries from the writing data like commands, insert or update. This pattern is specifically used in the system where you would like to achieve the flexibility, scalability, and the performance. And now let's talk about a traditional application architecture. It has a different layer. CQRS vertically scales that application for you and provides you two different parts. One is the command and other is the query. So whatever the logic you write on one side, your other side is not affected. So let's understand this by another example. In a simple CRUD system, whatever the command you write, you expect the same output on your query. But when you convert this in the CQRS, it provides you two different subsystems. One is the command, so whatever the data you write, you can have entirely different objects for the same data on your query side. And why is that? So, for example, you have an e commerce system where you have lots of leads and lots of concurrent users. Your system is read heavy as well as the write heavy. So, in the situation like this, you need to maintain the performance, scalability, and maintainability of your application. So, whatever the logics you implement on one side should not affect the other side. So, biggest advantage of CQRS is that two subsystems can evolve independently without interfering each other. For example, I apply the caching logic on my query side to improve the performance of my queries, then this will not affect my command side. Or you have one main database and you would like to reduce the load from your one database, and you will create a different replica read sets of your database for the query, then you can have easily in the CQRS and it won't affect on either side. The biggest advantage of this approach is, for example, your one database is down for some reason, then other database will be available to serve. Or you can have pre-computed views to enhance the performance of your each site. You can have event sourcing as well as eventual consistency in CQRS, but that is not necessary. Or you can have two different databases for the each site, and this is what I'm going to demo you in my next section. So because of this separation of concern, you have the liberty to apply any business rules or any logic on each side. If we talk about the command side, then you can implement the complex logics like validations, domain-driven design aggregates, or idempotency easily. Because of having two separate subsystems, we can achieve the separation of concerns, security, scalability, maintainability, and performance for our application. And now let's understand the communication model in the CQRS with the help of this architecture diagram. So for example, you wrote a command and after executing all the validation, you trigger the event. You can use RabbitMQ, Kafka, Amazon MQ, or any event sourcing system. So once the data is saved, then then your query side will be actively listening all those events whatever you are pushing from your command side, and once it's consumed the event, then it extract the data and save that in the query model database. So this is how the CQRS communication model works.